Look at the square shown here. Its size is unknown, so let its sides be x centimeters to find the area of the square. The area of the square is equal to x squared. If we increase each side of the square by 5 centimeters, the sides of the new square will be x plus 5 centimeters. Therefore, the area of the new square will be x plus 5 whole square. You can write x plus 5 whole square as x plus 5 multiplied by x plus 5. You can further simplify this algebraic expression by applying the distributive law. First, multiply x by x plus 5 and then multiply 5 by x plus 5. Next, multiply x by x and then by 5 and multiply 5 by x and then by 5. On solving this, you get x squared plus 5x plus 5x plus 25. Now add the like terms in the middle of the expression to get x squared plus 10x plus 25. Apart from this method, there is a shorter method to simplify the expression x plus 5 whole square. Let's find out what it is. To simplify algebraic expressions such as x plus 5 whole square by using a shorter method, you need to learn about identities. To understand what identities are, look at the equality shown here. Let us evaluate this equality for the value of a to check whether the left-hand side is equal to the right-hand side. Take 2 as the value of a. In the left-hand side of the equality, substitute a with 2. On substituting, you get 4 plus 6, which is equal to 10. Next, in the right-hand side of the equality, substitute a with 2 to check whether the result is 10. On substituting a with 2, you get 2 multiplied by 5, which is equal to 10. For 2 as the value of a, both left-hand side and right-hand side will be 10. Therefore, the left-hand side is equal to the right-hand side. Now, evaluate the equality for another value of a, say 3. In the left-hand side of the equality, on substituting a with 3, you get 18. In the right-hand side of the equality, on substituting a with 3, you get 18. Therefore, for 3 as the value of a, the left-hand side is equal to the right-hand side. An equality that is true for any value of its variable is called an identity. Is an identity different from an equation? Let us find out with an example of an equation. Say 5x plus 10 is equal to 2x plus 19. Let us evaluate this equation for any value of x, say 3. When you substitute x with 3 in the equation, on evaluation, you get 25 on both left-hand side and right-hand side. Therefore, the left-hand side is equal to the right-hand side. Now, let us see the outcome when x is substituted with another number, say 1. On evaluation, you get 15 on the left-hand side and 21 on the right-hand side, both of which are not equal to each other. Therefore, the left-hand side is not equal to the right-hand side. Similarly, if you substitute any value other than 3, you will find out that the left-hand side is not equal to the right-hand side for this equation. An identity is true for all values, while an equation is true for a particular value. An equality that is true for a specific value of its variable is called an equation. Therefore, an identity is different from an equation. You will now learn about 4 standard identities. Consider the equality shown here. Let us find out whether this equality is an identity. We will do this by proving that the left-hand side is equal to the right-hand side of this equality. The left-hand side, which is equal to a plus b whole square, can be written as a plus b multiplied by a plus b. By using the distributive law, it can be simplified to a multiplied by a plus b multiplied by a plus b. On further simplifying the expression, you get a square plus ab plus ba plus b square. Since ab is equal to ba, adding the middle terms results in 2ab. Therefore, the final result is a square plus 2ab plus b square, which is equal to the right-hand side of the original expression. Since the right-hand side is obtained by the actual multiplication of the left-hand side, this equality is an identity. Identities can be used as an alternative method of solving multiplication problems of binomial expressions and numbers. You will now learn to use the first identity, a plus b whole square, to solve the binomial expression 5x plus 8y multiplied by 5x plus 8y. Note, this expression can be written as 5x plus 8y whole square. Compare the new expression with the left-hand side of the identity. If you substitute a with 5x and b with 8y in the identity, you can simplify the expression much faster than that by using the distributive law. Let us see how. Take the right-hand side of the identity and substitute a with 5x and b with 8y. Simplifying the 3 terms, you get 25x square plus 80xy plus 64y square. Now, you will learn to use an identity to find out the square of 205. 205 can be written as 200 plus 5. Now, compare the new expression with the left-hand side of the identity, a plus b whole square. You can substitute a with 200 and b with 5. Take the right-hand side of the identity and substitute a with 200 and b with 5. On simplifying the 3 terms, you get 40,000 plus 2,000 plus 25, which is equal to 42,025. You will now learn about the second standard identity. Consider the equality shown here. Let us find out whether this equality is an identity. Take the left-hand side, which is equal to a minus b whole square. It can be written as a minus b multiplied by a minus b. By using the distributive law, it can be simplified to a multiplied by a minus b plus b multiplied by a minus b. On further simplifying this expression, you get a square minus ab minus ba plus b square. Since minus ab is equal to minus ba adding the middle terms results in minus 2ab. Therefore, the final result is a square minus 2ab plus b square, which is equal to the right-hand side of the original expression. Since the right-hand side is obtained by the actual multiplication of the left-hand side, this equality is an identity. You will now learn to find out the square of 98 by using another identity. 98 square can be written as 100 minus 2 whole square. The new expression can be compared with the identity a minus b whole square. If you compare the left-hand side of the identity with 100 minus 2 whole square, you can substitute a with 100 and b with 2 on the right-hand side of the identity. To get 100 square minus 2 multiplied by 100 multiplied by 2 plus 2 square. Calculating the right-hand side further results in 10,000 minus 400 plus 4, which is equal to 9,604. You learnt to use the second identity a minus b whole square to calculate the square of a number. You will now learn to use the second identity for solving the binomial expression 5b minus 8 whole square. If you compare the binomial expression with the identity on the right-hand side, you can substitute a with 5b and b with 8. On substituting, you get 5b whole square minus 2 multiplied by 5b multiplied by 8 plus 8 square. Calculating the right-hand side further results in 25b square minus 80b plus 64. You have learned to use the two identities to simplify binomial expressions. Let us look at the square that we saw in the beginning. When the sides of a square are increased by 5 centimeters, the area of the new square is equal to x plus 5 whole square. We simplified this expression by using the distributive law, which was a long method. Let us evaluate the expression by using the identity a plus b whole square. In the right-hand side of the identity, substitute a with x and b with 5. You will get x square plus 2 multiplied by x multiplied by 5 plus 5 square. On further simplifying the right-hand side, you get x square plus 10x plus 25. Therefore, using identities is a shorter way to simplify expressions or solve multiplication problems. Now, you will learn about the third identity. Consider the equality a plus b in brackets multiplied by a minus b in brackets is equal to a square minus b square. Let us find out whether this equality is an identity. Take the left-hand side of the equality. Using the distributive law, the left-hand side can be written as a multiplied by a minus b in brackets plus b multiplied by a minus b in brackets, which is equal to a square minus ab plus ba minus b square. Since ab is equal to ba, you can cancel the two terms in the middle to get a square minus b square, which is equal to the right-hand side of the equality. Therefore, the equality a plus b in brackets multiplied by a minus b in brackets is an identity. You will now learn to use the third identity in solving the product of two binomial expressions 8r plus 3t multiplied by 8r minus 3t. If you compare the binomial expression with the identity, you can substitute a with 8r on the right-hand side and b with 3t. On substituting, you get 8r square minus 3t square. Calculating the right-hand side further results in 64r square minus 9t square. You will now learn about the fourth identity. Consider the equality x plus a in brackets multiplied by x plus b in brackets equal to x square plus a plus b in brackets multiplied by x plus ab. Let us find out whether this equality is an identity. Take the left-hand side of the equality. Using the distributive law, first, multiply x by x plus b in brackets and then multiply a by x plus b in brackets. Next, multiply x by x, x by b, a by x and a by b to get x square plus bx plus ax plus ab. Note that the middle terms bx and ax have x as the common factor. So, factor out x from the middle terms to get x square plus a plus b in brackets multiplied by x plus ab, which is equal to the right-hand side of the equality. Therefore, the equality x plus a in brackets multiplied by x plus b in brackets is an identity. You have learned about 4 standard identities. Now you can use a suitable identity to solve the expression 4x plus 9 in brackets multiplied by 4x plus 7 in brackets. Note that the fourth identity is the most suitable to solve the expression. By comparing the left-hand side of the identity with the expression, you can substitute x with 4x, a with 9, and b with 7 on the right-hand side of the identity. On substituting, you get 4x whole square plus 9 plus 7 in brackets multiplied by 4x plus 9 multiplied by 7. On simplifying the expression, you get 16x square plus 64x plus 63. Let us now use a suitable identity to simplify the expression 7p minus 5q whole square plus 7p plus 5q whole square. Note that 7p minus 5q whole square can be solved by the second identity. And 7p plus 5q whole square can be solved by the first identity. So, the expression is equal to the right-hand side of the second identity plus the right-hand side of the first identity. So, on replacing A with 7p and B with 5q and then simplifying the right-hand side, you get 49p square minus 70pq plus 25q square plus 49b square plus 70pq plus 25q square. Note that we can cancel out minus 70pq and plus 70pq with each other and add 49p square and 25q square to get 98p square plus 50q square. Let us summarize the key learning from this topic. An identity is an equality that is true for all values of their variables. You learned about the 4 standard identities. These 4 identities can be used as an easier way to find out the squares of expressions and simplify algebraic expressions.